This is problem 122 of Neetcode 150, maximum subarray. So we're given an array of integers, and we have to find the subarray with the largest sum and return the sum. And the subarray has to be contiguous, meaning that you cannot take, for example, this 2 and then just skip this 3 because it is a minus 3. No, you have to take it because it is adjacent to this 2. So you could have 2 minus 3 plus 4 minus 2 plus 2 plus 1. In this case, I'll let you make the calculations, but you will get that sum, or you can take minus 2, you can take 2, you can take 1, you can take minus 1, and you can take 4. In this array, you're going to have 4 because these are basically canceling each other's. And you can also have this, this 4 here. So what is the strategy here? Well, let's first go through a brute force approach. A brute force approach with a time complexity of big O of n squared will be to go through every single number, and for every single number, try adding the one that is next to it. So now we initially add a 2, then we're going to try 2 minus 3, then we're going to have 2 minus 3 plus 4, then we're going to have 2 minus 3 plus 4 minus 2 up to the n. And once we reach the n, we're going to start at minus 3, so we're going to say minus 3 itself, then we're going to have minus 3 plus 4, then we're going to have minus 3 minus 2, and then we're going to have minus 3, 4, minus 2, 2, and then we're going to start at 4 once we've n all the numbers. Okay, so let's just go see what this looks like in code. I think it is quite easy. So let's say that we keep our max s of, and we set that initially to the very first number. So we have an index to refer it to. And now I'm just going to say for I in the range of length of the nums, and for g in the range of starting from I up to the length of the nums. So this is how we're going to go see all the other numbers. I initially want to have sort of a temporary variable that will holds the current state of the sum. And what I will do is that I will just add temp. I will add to temp the nums at the index I or the index g, and I will set the max s to be equal to the maximum between what it currently is, and also the temporary variable that we have, so that basically we're gonna do every single possible combinations, and at every single combinations we're gonna go see what this sum is, and is it greater than the current maximum value we've seen so far. And at the end we can return the max s. So that is a brute force approach. It works. It is gonna go for every numbers to every numbers. So we're gonna go through every n for each n, meaning we're gonna have a time complexity of big O of n squared. Its space complexity is gonna be big O of 1, so that's good. But how can we actually have a time complexity of big O of 1? So is there a way to actually go through every single number only once? Well, yeah, there is. So well, to do so, we know that we can have 2 for loops that will create basically a n squared time complexity. So we're gonna have basically a loop that goes through every numbers. So for num in nums. So this is what we know we are gonna have. And is it possible to actually go through every numbers and then at the end just return the max s and expect to actually have this greatest value? Well, yeah, and let's see why. Okay, so let's take a look at this. All right, so in our first example, we start in the maximum sum is the first number, so it's going to be 2. And then we're going to add the next number, so we're going to have minus 3, meaning that at this particular place, this entire thing is going to equal minus 1. And when we go to the next value, we have 4, right? With our 4, do we really care about adding this negative value? I mean, is it ever going to increase our sum? Because we can just take this 4 by itself and consider it to be a sequence and add this as the maximum value. So why will we take what we did so far if it is a negative value? Right? It doesn't really make sense. So this is what we're going to do, okay? So we call our temporary variable. We're going to keep a temporary variable as well in this way of solving this problem. And what we will do is that we will just check if the temporary variable, if this is negative, if this is smaller than 0, set this back to 0, meaning that we are just not going to care about the previous value before. And then I'm going to add to this temporary the, the current number that I'm at. All right. And then I will set the max s to be equal to the maximum between what it currently is and the temporary variable. And I mean, do you think that this code will work? We're going only once through every single number, right? So this is pretty efficient. And we're also setting the max s to be equal to the first number inside the array. So we have like a secret baseline. And then we're going through every numbers and we're just adding them to this temporary variable. And basically, if we reach another number and notice that the sum of all the values before these current numbers are negative, well, we notice that there's absolutely no advantage of adding this previous sum inside our current sum. So we're just going to set this back to 0, and we're going to add this num in it. So if we take a look at this, can we actually reach an output of 8? Well, let's see this, okay? So let's say the output right now is set to 2 because this is the first number. So we're going to go ahead and see the second numbers, which is a -3. So the temporary variable will be -1. So now we'll go to 4. And since -1 is the previous value, we're just not going to care about it. So we're going to set the previous value to be 0. And we're going to add this 4 to this. So now we have 4. And we're going to compare basically the previous maximum sum, which used to be the first number 2, with that current state. So we have 4, which is greater than or 2. So now at this point, at the third entries inside our array, the output is currently set to 4. Now we go see the next value, and we have something positive. So we do want to take our 4 in because the maximum sum of all these previous value in a contiguous way, of course, is going to be 4. So yes, we do want to add our 4 in the next value because it's going to increase the current value, right? Even though we are decreasing this by 2, we are still going to add on our total sum by adding 4 plus this. So these two will equal 2, right? So now 2 is not going to beat the previous output of 4, but still 1 will be at this position, at this 2. We'll have basically a previous value of 2. So this is positive. This is going to increase our maximum sum so far, or temporary variable. So we're going to add this to the current value, which is 4. Which is 2, right? So we're going to add 2 plus 2, so it's going to be 4. But 4 is not going to be greater than the current output, which is 4. So we're just going to keep this to be 4. And now when we'll be at this number 1, we'll see that the greatest value we can have by adding numbers in our previous values will be 4. So we're going to add 4 to this 1, and now we're going to have a current sum of 5, which is greater than the output. So we are going to set the output to be 5. And now we're going to go see this -1, and we will see that the greatest value we can do with the previous numbers that happened in the array is 5. We're going to decrement this by -1. So we're going to be at 4. And this is not going to be the output, which is going to be set at 5 at this point. But when we're going to arrive at the last value, we are going to look basically at what is the greatest value we can do with a contiguous sequence of numbers that comes before this 4. Well, we are going to have 4. So we're going to add 4 plus this current value, which is 4, which is going to give us an output of 8, which is greater than the previous output of 5. And this is going to give us this output 5 that we're seeing down there. So is it going to work? Well, let's test this out. And yeah, it works. So notice that we're going only once to every single numbers for num and nums, and we are not storing any additional memory. So we're going to have a space complexity of big of 1. I hope you enjoyed this video. I hope you found this instructive, and I hope to see you in the next one.